Welcome to a new test and teardown video. This time it's a Philips GM2889 FM AM generator. And this one is from about 1953. The output is from 5 to 220 megahertz. And it's of course fully tube based, but there's also a mechanical adjustments tuning kind of system that will affect one of the oscillators. The way that this one works is a little bit special, since you can see we got the two dials and we can adjust the frequency of both of them. The output frequency is of course what we see here, right? But they are actually much higher frequencies, both of these two oscillators. I think it's between 275 to 450 megahertz or something like that. This one is, and the other one is about 260 to 70 megahertz. And then they are mixed together, and that is the output we got here. There's of course a filter, low pass filter, and all that kind of stuff as well. Yeah, I think that is more or less the introduction. It is 17.4 kilos, and it is quite big. The rear of this unit reveals the type number. See this -01, so this is the first release of this model. 40 watts, okay, that is also very important for my debugging session. Oh, yeah, look at this mains connector here is like the big hefty ones, and we can actually also see, I don't know if that is easy to see on the camera, maybe if I put some light somehow, but we got extra internal shields inside. So now we're inside this fantastic unit, and exactly what I said, there is this wobbler. They call this a wobbler unit, but it looks so much like a loudspeaker. See, there's a voice coil in here, and it can of course move. And this, we can see here, there's a little stick that goes through here, and it is of course tuning one of the oscillators in here. That will be the magnets and everything like that. So it looks very much like a loudspeaker. And the magnets gotten some little metal thingies on it here. So. And you can probably hear this when this is moving. It's going to make a buzzing sound, I would suppose. And that will be the rectifier tube. Here on the side, there's a little switch. And this one, of course, you need to unscrew from the cabinet when you remove the cabinet. Let's look a little bit more inside this unit. It's absolutely amazing. So we got two oscillators, like I already talked about. So here is one of them, and we got two tubes right here. This is the ECC81, so that will be two triodes. And up here we got also an ECC81, and in here, in this, I think is also another one of the mixer amplifier or something like that. We got the diode right there, and we got the EC81. So this is a single triode. And down here, look at this little silver part here. Yes, here. Oh, let's see if I can get this in focus. Come on, man. Yes, no. This one is, see, if I move this, if I touch the little speaker. So this capacitor here is actually the modulator. It's a little bit difficult to video because we got so much stuff in the way. And I believe this is probably the mixer and output system right here. So we see one of the oscillators is driving this system here, and this is where all the wobble modulation goes, and then we see the 2 oscillators goes into this mixer system. So another EC81, and that will be, of course, the low pass filter that removes all the very, very high products of the 2 oscillators, and this way only 5 to 220 megahertz is output. And here is the high frequency oscillator. It's running, I mean, more than 400 megahertz, and they're using an EC81. So how are they doing that is a little bit interesting. They don't even use a normal socket for the tube. Look at that. So they're trying to get capacitance and everything, inductance around this as low as possible. They're using feed through ceramics, and they're using all sorts of special tricks. And down here is the tuning, the variable capacitor. Yeah, we can see it a little bit. Right, it's impossible to view. Here we go. So that one. And the gearbox is also a little bit interesting. Let's see if I can see. This is the readout. So the aluminium one here is the readout, and there is a, yeah, like that. So there is a little steel wire that goes from this, this wheel to the left. That is, of course, the capacitor. And this one to the right is the readout. And then here, down here to the left, the one down there that is made of brass, that is the knob on the front, and it's geared like that. Isn't that amazing? Let's look at the bottom of this quite the special unit. See, that will be the output connectors they're using. They are, I think they look quite special from the outside, but on the inside here it's just, of course, just coax cables, and then why this long flippity floppity wire, and then all this, I mean, just don't make good sense, does it? And wire wound potentiometers, and they are, yeah, full of what appears to be fungus. Why is it I always get those fungus infected things? But yeah, and that'll be, oh, look at that, a little glass feed through. How nice. But I still don't find any leaked capacitors, anything that's blown up. So let's try and power this up and see what's gonna happen. Oh yeah, this is, it looks like a little spring, but this is actually a fuse. So when this one is overloaded or overheated or something like that, then this one will trips. I believe it's up here. This is a soldered joint. This is a little bit, so you can actually move up here. But the idea is this solder that is holding this one will melt at a quite low temperature, and then flop, disconnect, and then we don't see any nasty fire or anything bad going on here. Let's look a little bit here at the block diagram. I think this shows a little bit more loud and clear what is going on in this unit. See, in the upper left we have one of the main oscillators, and this one is running from 275 to 495 megahertz in using this EC81 tube, and this is a little bit impressive, by the way. And then they just have this diode symbol. So this is the mixer. So the mixer makes the sum and the difference. That is actually the idea. And the other oscillator is about 270 megahertz, plus minus a little bit. It's not a very lot. And then we have, of course, a low pass filter, and then you have the output. And we also have a lot of frequency modulation, this little wobbler unit that detune one of the oscillators. We in the bottom left we see the crystal oscillators, and they can be mixed together with a 400 hertz oscillator as well. You can also select 50 hertz for the wobbler, and all these different frequencies and modulations. They're just controlled using some of the potentiometers. Here is almost the schematic. Well, this is a much later model, so it's not exactly the right schematic for my version. Mine is, of course, version 1, and I think this is version 10 or something like that. So there's a big difference in what kind of tubes they're using and how many tubes they're using. But let's not go into super detail about this. We will see the 400 cycle oscillator in the upper right. That is very different in my unit. We're using a few more triodes, and also the crystal oscillator options and all that is in the upper right of my unit. But the cool and interesting thing is very much in the middle of the top of the schematic. This is where we have this sweep wobbler thing, and this is controlled by a potentiometer that is connecting to a supply voltage, and by turning this potentiometer you can get more or less AC into this loudspeaker, and the loudspeaker controls of course the mechanically this capacitor, and this detunes unit C oscillator. Unit A is the wide band and high frequency oscillator, 275 to 495 megahertz, and we can also see the little coupling capacitor they call C5. In the previous clip you saw that they were just using a little cable where two ends of this, it's actually a twin lead RF cable, and they're using two of the halves of this cable as a capacitor to couple this very, very high frequency into the grid of the triode tube in unit B, while the cathode is the much lower frequency from unit C. So I think that is more or less how this unit works. So let's slowly try and power this up. I think I'm doing everything right. So this is the HF output. Let's just give it a little bit more. It goes from 0 to 10. I don't know exactly what that is. Is it volts or something like that maybe? And I don't have the right connector, so I just put in a little diode just to fit in there. So hopefully this will give us something. And this is, of course, mains is turned on, and external modulation. So probably sweep. Okay, so let's crank down. The sweep is down. And then let's just slowly power it up and see if there is any. Yes, it is using a little bit, so the fuse is good. So this is the first 100 volts, and it is using 7 watts. So of course we're not warming up anything. Remember, we need to warm up the rectifier before we see any high voltage. So this is 180 volts, and it's using 17. So I think we should just go all the way to 220. Let's go down again. Okay, 220, and it's using 25 watts. Oi, I got a shock. I know why this relay just activated. So there's a time delayed relay. So that of course spooked me. but for no reason. So let's just try again. Stop being so spooked. So here we go. Will we see click? So that was normal. So that is the relay. We don't see any output. What am I doing wrong here? Okay, so that has something to do with modulation, 400 cycles modulation. So I get so this is not what I see. That is weird. Because look at that. See, this is not HF output. This is the modulation. Okay, so we get modulation, but we also, I think there's probably a little bit of RF on top of this. Hey, we should probably get a spectrum analyzer and check it out. Look at that. That would be, and it's full of DC. Ooh. So I will have to put an attenuator. Why can't we see anything? Oh, full. Okay, I think I figured something out. So look at that. One oscillator here is working. Look at that. But for whatever reason, the other oscillator here to the left, this one over here, see, there is no response whatsoever. So that is what we are missing. We need both of those two high frequency oscillators to actually give us a good output. So what we see here is just some random instability or something like that in this oscillator right here that for whatever reason give us this result. So yeah, I'll go and check out what's going on in this left oscillator. So I put in 2 new tubes in the left oscillator system, and look what we have here. You can now see we got some oscillator that is doing some stuff here. I don't know, we can't really see that. Yes, here we go. So this is one oscillator, and the other one, see, is also doing some funky stuff. And they are, of course, mixed together. And I think this is really not super visual what is happening on the scope. So let me see if I can find something else. Let's play with that. So here is a little spectrum analyzer, and I hope this will show a little bit more what is going on. So at the moment we see a sweep from 0 to 500 megahertz, and hopefully when this says clickety click, see, oh yes, can you see? We got some frequencies, we got some stuff going on here, and when I dial around here, see, we can move. I think it's actually funny that it goes all the way out of the scale. So this one here is interesting. So how about this one? Oh, it's down here. So it's actually just two outputs that is moving, and then it goes away. And they aren't really mixed. They're just added. See, they don't generate the sum correctly. Let's see if we can get a little bit higher stop, like 600. Ooh, look at that. Oh yeah, it goes and goes and goes. That is interesting. It peaks here, for example, right? And then this is the most unstable, absolutely useless behavior. If you want all sorts of random funky pulses, then here you go. What the heck is going on? I love it. It's just totally useless. Oh man, this cannot be the way that it's supposed to be working. I mean, look at this. It's coming and going and all sorts of randomness. Of course, maybe I can change some more tubes and see what's going on here, but I think this is how it's supposed to be working. I just went up and got a brand new EC81, so that will be the mixer triode, and it did help a lot on the level of the high frequency. See, here's 385, but I mean, there should be a 200 megahertz low pass filter. And the thing is that they're still not mixing the two oscillators together anyway. So I'm not going to play anymore with this one today. This is just a little bit annoying. There's just, for whatever reason, not mixing on it. Anyway, I think that is what I wanted to show. So thank you for watching. Bye bye.